Okay, so for this problem we are looking at the graph of the derivative based on the graph of f of x. Graph of f of x is a linear graph. That is important. If it's not linear, we're not going to be able to get an exact graph of the derivative, at least not yet. We need the function in order to do that. With a function, I can take the derivative, I can do the limit as h approaches 0, calculate the derivative, and then graph that. With this problem, I can't do that because I don't know what the function is. I could figure it out. They are just lines, but we're not going to do it that way. Instead, we're going to utilize what we know about lines, the fact that a line has a constant slope. So I'm going to start with this first piece right here, and I'm going to find the slope of that line. I could choose any coordinate that's on that line. I'm going to choose the first coordinate and the last coordinate, these two. Those two endpoints are what I'm going to use to figure out the slope of that line. So I'm going to plug into my basic algebra slope formula because I have two coordinates, y2 minus y1 over x2 minus x1. So my coordinates are -3, -2, that's the beginning coordinate, and -1, 2, that's the ending coordinate. So my y values are going to be 2 minus -2, and my x values are going to be -1 minus -3. And so if we work that through, 2 minus -2 is 4, 1 minus -3 is 2, that equals a slope of 2. So what that means is this graph always has a slope of 2 at every point, at this x value, at this x value, at all of these values, x values, on this graph, they all have a slope of 2. So starting from -3 to x equals -1, I'm going to plot that on my graph. So I need to get rid of my slope work here. I'm just going to write up there that I still have a slope of 2, so I don't forget that. So the slope of this line is still 2. And then I can plot it on my graph down here. So at -3 to -1, my slope is 2. And so I have this horizontal line because the slope is always 2. At x equals -2.9, my slope is 2. At x equals -2.1, my slope is 2. At x equals -1.5, my slope is 2. The slope is 2 throughout those x values. When I go to the next piece is this horizontal piece right here. Now I could calculate the slope. I have two coordinates. My coordinates are, if I use the endpoints, my coordinates are at -1, 2 and at +1, 2, but I don't think I need to do that math. I think it's pretty obvious that the slope there is 0. And so from x equals -1 until x equals +1, I have a slope of 0, and so I can graph that on my graph of the derivative. Just darkening it in a little bit so we can see that we've actually gone over the x-axis. That's a slope of 0. The final piece we start at the coordinate 1, 2, and we end at the coordinate 3, 0. We can calculate that slope. I could do the math to calculate that slope, but I think that we can figure that out without too much issue, and we should be able to see that that slope is -1. Right? We don't even need to calculate the slope. We can easily see that we're going down 1 and over 1, going down 1 and over 1, and so that slope is -1. I can plot that. That is from x equals 1 until x equals 3. So starting at x equals 1 until x equals 3, we have a slope of -1. Now we're almost through with our graph of f of x. This is the graph, our graph of f prime of x. This is the graph of f prime of x, except for at all the endpoints. The endpoints of the three pieces at x equals -3, -1, +1, and +3. What we talked about before that dealt with continuity is the same thing that deals with derivatives. If the derivative from the left side is not the same as the derivative from the right side, then the derivative does not exist at that point. Endpoints never have derivatives, so at x equals -3, we're going to use an open dot there. For x equals 1, the slope, at x equals -1, the slope on the left side of -1 is 2. The slope on the right side of -1 is 0. Those two are not the same number, and so there's no slope there, so I can't have a colored in dot there at all. So I have to have an open end dot here and an open end dot here. Same argument at +1. The slope from the left side is 0. The slope from the right side is -1, and so we don't have a derivative there either, so we use open dots. And then finally at x equals 3, that's an endpoint. We're going to put an open dot there as well. And so there is our derivative graph. having all of the coordinates set up with linear pieces. Again, if this were curvy, you couldn't do it. We couldn't graph it, and at least not right now. We could get a sketch, but we couldn't graph it exactly. If you're looking for an example of sketching, my next video will show a graph of sketching the graph of a derivative that is based on a curvy f of x. But with linear, they're always going to look like this. They're called step functions. They're just going to be pieces that are all horizontal because the slope is constant in a line.